So now, before we use the 74HC14 integrated circuit and some other circuits, we're going to just look at the basic use for it. So you have to power it, positive supply to the top right pin right there, and then negative supply to the bottom left. That's not the divot to indicate the top, it's actually up there. But any case, we're using one of these 6 NOT gates. The other NOT gates that we're not using, I tied to the positive supply their inputs to stabilize their outputs. And so we're given a signal to the input of the top left NOT gate right there. You can see we got a lower voltage there, but we got the negative supply to the LED there, so we know that the output is high. So low enough voltage, output's high. High enough voltage to the input, then we have a low output right there. So that's the NOT gate. The output is the opposite of our input. The output can provide, enough current to light LEDs basically right there, whereas a trim pot cannot. So now, here we have a circuit. The lamp is at its brightest setting. We have a low output. Now the lamp is at a dimmer setting, the dimmest now, and we have a high output right there. There's also hysteresis, so some settings it could be either high or low, the middle ground settings. But in any case, we're using a NOT gate just because why not? Let's learn more about NOT gates. The NOT gates we are not using are tied to the to the positive supply to stabilize their outputs. Negative supply down bottom left, and then positive supply top right over there. But in any case, we have light falling on the light dependent resistor. More light gives you a higher voltage. High enough voltage, you have a low output, as we see here. We dim it, we have a 10K resistor going to the negative supply, making it a voltage divider right there. Now it's lower voltage because there's less light on the light dependent resistor, and that gives us a high output. So that's what makes it a NOT gate, but it's a light sensitive NOT gate. So now, the circuit we're focused on, here's the schematic, is the 74HC14 integrated circuit. There's 6 NOT gates that have Schmitt triggers. And so in any case, whatever the input is, the output power will be the opposite. So you give a high in, you'll get a low out. You give a low in, you'll give a high out. Pretty simple. The demonstration we just did, we used a 10K resistor right down here that helps adjust the sensitivity. But in any case, a bright enough light, you get a high input. And then the output will go low. The blue LED will light up the way that I wired this up. Now, if we make it dark enough, you get a low input right there. Again, the value of the resistor adjusts the sensitivity. But a low input will give you a high output, and therefore the red LED will light up. Like the 555 timer, this probably does not get to the positive voltage as well as the negative. But any case, that's the basics of the circuit. We looked at the 10K, now let's look at the 1.5K. So now we come back to our NOT gate demonstration circuit where we have a light dependent resistor. So bright enough light sets the output low. You get a higher enough voltage, you get a low output. But the lamp's at its brightest setting, it's still not bright enough. I actually have to use the side of the flashlight right there to get the output low. So now we got a high enough voltage input to get a low output. That is the main thing with the NOT gate. Output is opposite of input. Now, if I use the front light, I was using the side light, both LEDs are actually alternating right now. And that's because the hysteresis range isn't big enough to overcome a rapidly flashing light like this right there. So that's something to be aware of. If it looks like both LEDs are on, they're actually alternating really quickly right there. So again, we have our light dependent resistor voltage divider. I'm using a lower value resistor, 1.5K instead of 10K, to make it so we need more light. That's how you adjust the sensitivity.